Hi everyone, I am Vinayak D. Badge from Mechatronics Department. Today I am here to explain about my project battery swapping of an electrical vehicle under the guidance of Ramya P. Ma'am. And my team members are Samet Balaji, Prashant Kumar N, Puneet Kumar S, and Shri Varshan R. Today I'll be covering introduction, literature review, and reference of my project. Okay, introduction. Well, Going to the topic, let us understand battery swapping technology. Today, recharging a EV batteries takes long than 30 minutes to few hours. When comparing to a refueling of an conventional vehicles takes only few minutes. An emerging sectors of automotive industry battery swapping technology. It offers the way of switching discharging package with fully charged one. This can minimize the time speed waiting of EV batteries to recharge the battery bags can exchange in a battery swapping stations with fully charged ones. Where the development of an electrical vehicles is widely favorable for by a large and growing to a potential to reduce fossil fuels based on the resource and according to the reduction and consultant environment impact. It anticipates that EVs will take 8.3% of automotive market by 2022. Going penetrations of EVs can potentially reduce emission, save fuels, cost of EV owners and reduce the consumption of gasoline. It can also increase the utilization of renewable energy such as wind and solar sources. Battery charging play an important role in adaptivity of EVs. The current charging scheme is mostly based on the plug in the EVs into an outlet, either the individual outlet or in a battery charging stations. These methods takes much longer than fueling a gasoline power, which has present a shortcoming to barrier to EV adoptions. The infrastructure of the EVs itself a foundation. The many different types of EV such as plug-in electrical vehicles and plug-in hybrid electrical vehicles are remarkable in many ways, such as their independence of the fossil fuels and the financial saving, lack of emissions, safe driving, decrease in noise, easy to maintenance, etc. Notwithstanding, such as encouraging the data, the EV business is warmly welcoming the development of EV technologies as a source of satisfaction. The benefits of battery swapping system includes the fast charging. In constant to the hours, it takes a few charge of battery using conventional charging techniques. Replacing an exhaust battery with fully charged one only takes a few minutes. Range extension. With the battery swapping system, driver may quickly change out his battery discharge battery with that is fully charged, enabling them to keep going for long distance with stopping from a draw out charge. Reduce battery degradation. Since the battery in electrical vehicles are not conventionally being charged and discharged, battery switching can be assist decrease the deterioration of the batteries. Convenience. Battery swapping system may be found at a place that a convenience for a driver for electrical vehicles to recharge the vehicles such as gas stations, rest areas or parking lots. It eliminates the long charging time, thus save in the time. The charging needs a huge large parking station infrastructures, thus is this eliminated as a battery swapping is quick. Lack of proper infrastructure of charging or a replacement stations. High amount of investment required for initial setups of the battery swapping stations. The battery housing of an EV designed in a special way to support a battery technology. Despite of all constraint, battery swapping technology is one solution for saving charging time. On ongoing improvement in EV battery swapping technology, that's bright future in our coming days. Our objectives are using renewable energy source can make this use of electrical vehicles more eco-friendly. Battery swapping is quick and cost-effective method of recharging an electrical vehicle, utilizing intelligent transport system technology to enable the efficiency. This is the block diagram of our project. We are using a solar energy. where the solar panels are placed on the above the vehicle. We are using a controller, solar controller. We are controlling the energy, whatever the energy getting from the solar panels, it is controlled by the solar charge controllers. Then it is sent to a battery management system where we are seeing our output in the cloud, where we can see the battery level and the charging of the charging level of the batteries, where we are using two batteries for in our project, where battery 1 and battery 2. Whenever the battery 1 is in the discharge mode, battery 2 will be in a charging mode. When battery 2 is in a discharging mode, battery 1 will be in a charging mode. Going to the literature, we have referred some pages, some IEEE papers. First paper is analyzing the user acceptance of the light electrical vehicles and novel charging infrastructures. As per the author, the in this project, the noise less traffic study of designing material and it is priority. Within our study, we define that acceptance subjects as a potential user of the light electrical vehicle sharing services and energy supply concepts such as CSCS and B battery station service, or a people who reject the use. Checking for ability of the slot before coming for a service. The it is very difficult for a driver to battery station in the rural areas. In the second paper, we referred real-time operation management for a battery swapping charging system via multi-agent deep reinforcement learning. As per the author, the advantages of this paper was the battery swapping charging stations can provide a better battery swapping services for the electrical vehicles in large cities. In BESCS, EV batteries can be externally charged at a battery charging stations and dispatched via delivery trucks to battery swapping stations. To support a local EVs, the paper consider the real-time optimization scheduling problem in BESCS, including the battery charging, swapping, and the truck routing. In this paper, we the model joint scheduling problem of battery charging and the logistic in battery swapping charging system. In the third paper, the operation management of a electrical vehicle, battery swapping and the charging. As per this author, we consider that BESCS locally integrated battery swapping and charging processes. Each battery in the system is connected to the charging dock. With our study, we can access the data of the present level of the battery through the cloud using an app. The Android application of Swap Easy is helpful for user in urgent need of battery. The according to this, the connection problem in some areas access the data. From an economical point of view, battery swapping has long been considered as economically available than the mainstream option of plug-in charge. Considering the BSCS locally integrated battery swapping and the charging process, each battery in the system is connected to the charging dock. Where in the fourth paper, the battery swapping station in electrical vehicles, as per the author, the electrical or vehicle in a the vehicle is in transmit and the features can be accessed through the app. Within our studies, we can access the data of present level of battery through the cloud using the app. The Android application Swap Easy is helpful for user in the urgent need of battery. The data is stored in both the local and the remote storage location, which helps in the system operation even while offline. The connection problem is in some areas to access the data. Cloud tracking. The next paper, user-based battery swapping strategy in an electrical bike sharing system. The author says that integrated program mathematical model is established for user-based strategy and algorithm is applied to solve the model. Our strategy and algorithms are verified on the 30th instance with a different size. Finally, a real-world excess of EBSS or hollow bike in proves that benefits of the user-based battery swapping strategy. This strategy can help reduce battery replacement cost by 25.11% and place most power batteries quickly. Give, Given the high cost on the poor timelessness of the current batteries, swapping strategy in the EBSS, this study purpose a user-based strategy through a user sensitivities of low power e-bikes can be gathered at the some selected swapping stations which reduce the battery swapping routing distance of the truck. In the sixth paper, a semantic review of a dynamic wireless charging stations of electrical transportation. According to the author, the cost and the time estimate of the service or the maintenance job all in one management system. Both the service provided and the customer interface is available. Check for the availability of the slot before coming into the service. Build a suggestive system for a kind of damage or a repair battery needs. The main drawback of the survey, it takes more land space, needs to specific infrastructure. In the seventh paper, the study of electrical axis wind turbine with the solar PV for energy storage in the battery swapping of the electrical vehicles on a highway using. As per the author, the highway wind turbine study has been done to check the flexible and energy generation of the optimal design is created to provide enough electricity to store the energy in the battery swapping stations or in an energy storage device for vehicles. Movement air is generated due to the air friction to is used in a turbine that converts mechanical rotation into a electrical utilization generated and the wind air. The large area and the infrastructure is a setup is required for this project. According to the 8 paper, the data drive location selections for the battery swapping stations, the author, since the large scale of the data of a vehicle such as GPS locations and the electrical request can be connected to the data driver approach. The cost effective and the useful method to select the location of the BSS location selection problem in the green. The intelligent transport system, it is very difficult for a driver to the battery stations in the rural areas. In the ninth paper, the optimal design and the analysis of the hybrid power charging stations for electrical vehicles consider the uncertainties. As per the author, we are using they are using the renewable source BESS grid connected system and EVs and hierarchical energy management strategy was adopted for the real-time application involving many aspects. The consumption assumptions with the both MCS and the GA methods requires huge computations to make the simulation result more convenience variations on the electricity price and the sensitivity analysis. In the third paper, the autonomous battery swapping system for a scale small scale helicopters. The author says the system includes a battery swapping mechanisms and the online algorithm to address the source management, vehicle health monitoring, and the precision landing on the battery swapping mechanism landing platform. MIT has created a charging platform which allows UAV to land or recharge before resuming flight. The battery drain is more in a helicopter compared to the vehicles. The electrical power motor used in the electric aircrafts are heavier. The 11th paper, the battery swapping assist for electrical vehicles is a matching approach. As per the author, the formulate the problem of optimal solution assignment for a EV battery swapping that takes into account both temporal and the spatial coupling. We should that the problem can be reduced to minimal weight perfect matching of the problem. This leads to an efficient polynomial time solution. Numerical explain suggests that the proposed approach perform much better than the greedy the shortage in the supply of available batteries considering the optimal solution assigned problem at a time slot. In the 12th paper, As per the author, the battery swapping requirement for the electrical vehicles, and the concept for this was EV SBR. Adequacy is a driver for where the adequacy assignment of the power system of the reference of the battery swapping stations have the ability with the certain high probability of the supply enough full charge batteries at the hour time in order to satisfy the battery demands. Adequacy of the power system is evaluated through several indices, including the loss of load, acceptations, loss of load frequencies, and the acceptant energy not supplied. These are the references we are referring for our projects. Okay. In upcoming videos, we'll update with the methodology and implementation. This is our block diagram. The work is going on. Thank you.